नहीं, आप मेरी आवाज जा रही है?
Good morning, sir. Pawan sir, good morning.
Good morning. Good morning. How are you?
Prince sir, good morning.
Good morning, Amit ji.
Hey sir, very good morning.
I am audible. I am audible.
Yes, sir.
Okay.
Dr. Prince, I am audible. Hello. Dr.
Yes,
Prince?
you are audible.
Okay, thank you so much.
भाई सब लोग चुपचाप ना कुछ बोलते हो। डॉक्टर प्रिंस,
Yes, sir.
कुछ इको साउंड हो रही है इसमें।
Sir, I think two mobiles are very near to each other for someone. That's why this is happening.
Oh, maybe.
Now it is fine. Hello. Now it is fine.
हेलो डॉक्टर कौन?
Hello. Hello.
हाँ,
Sir, your voice is echoing.
I think somewhere.
Doctor, please check my voice. Is it clear?
Yes, yes.
Okay, thank you so much.
We are able to listen.
Okay. And voice is echoing or not?
No, this is fine.
Okay, thank you. Thank you so much.
Sir, good morning.
कान बनाने को लगता नहीं क्या
ये तो खुला है। बता रही कहाँ चला गया।
यही दो बना रहे
नहीं आएगी आएगी। पहले तो आ जाती थी।
चल थोड़ा सी कर
देखना पड़ेगा। क्या चीज़?
वो चल रहा है कार
I नहीं यार अमन एक और नंबर है ये नोट करो ऊपर वाला ये वाला नोट करो very good morning everyone. Am I audible?
Yes.
Okay. I request to all the participants, please mute yourself. I request all the participants, please mute yourself. Then you will be able to hear me. Dr. Utkarsh Saxena, please mute yourself. Dr. Pramod Kumar, please mute yourself. Good morning, everyone. I am Dr. Prince, Assistant Professor, Department of Physics, D.S.N. PG College, Unnao, Uttar Pradesh. I welcome you all to the national webinar on modern applications of nanotechnology and its future challenges. I am excited and enthralled to see so many research scholars and professors from all over the India joining this webinar. As a courtesy to our speakers this morning, I would request everyone to keep yourself on mute and kindly do not write good morning and good afternoon messages in chat box. We strive to make this webinar informative to everyone. So without further ado, I begin with the inaugural session with the worship of Goddess Saraswati. So for this purpose, I would like to invite Dr. Akanksha Srivastav, Assistant Professor, Department of Chemistry, D.S.N. PG College, Unnao, for the evocation of Goddess Saraswati. Dr. Akanksha Srivastav, ma'am, over to you.
Thank you, Dr. Prince, for giving me this holy opportunity. Goddess Saraswati is venerated by Hindus as the epitome of knowledge and speech. She is the patron of arts, music, philosophy, creativity, wisdom, and learning. Saraswati Puja helps invite the goddess of knowledge into our life for
मेरा फोन
mastery
लाओ, मेरा फोन
over
लाओ।
arts and success in education. So let's start the worship. या कुन्देन्दु तुषारे हारे धवला या शुभ्रवस्त्रावृता या कुन्देन्दु तुषारे हारे धवला या शुभ्रवस्त्रावृता या वीणा वरदण्डे मण्डिते करा या श्वेति पद्मासना या ब्रह्माच्युत शङ्करा या ब्रह्माच्युत शङ्करा प्रभृतिभिरे देवा सदा वन्दिता सा मां पातु सरस्वती भगवती निशेषजाड्यापहा शुक्लां ब्रह्म विचारे सारे परमा आद्यां जगते व्यापिनी वीणा पुस्तक धारिणी अभेदां जाड्यान्धिकारापहाम् हस्ते स्फाटिकमालिकाम् विदधती पद्मासने संसिधाम् वन्दे तां परमेश्वरी भगवती बुद्धिप्रदां शारदाम् वन्दे तां परमेश्वरी भगवती बुद्धिप्रदां शारदाम्. Thank you very much. Now, I would like to pass over the mic to Dr. Prince to proceed the webinar, Modern Applications of Nanotechnology and its Future Challenges. Thank you very much. Mic
Thank
pass
you.
over to Dr. Prince.
Thank you so much, ma'am. Now I would like to invite Dr. Pawan Srivastav, Head of the Department of Physics, D.S.N. PG College, Unnao, for the welcome address. Dr. Pavan Srivastava always encourages and motivates us to give involved in all academic activities like this webinar. Can I please request Dr. Pavan Srivastava to deliver the welcome address? Dr. Pavan Srivastava. Dr. Pavan Srivastava. Sir, are you able to hear me?
Am I audible?
Yes, sir, you are audible, sir. Please.
Okay. Thank you, Prince. Very good morning to you all, respected dignitary of all virtual platform today. The chief guest of today's webinar is Honorable Sri Manvin Saru, Secretary Board of Management, D.S.N. College, Unnao, who always encourage and motivate us for such type of program. Our principal, Dr. Manvin Singh, who regularly supported in all respect. Resource persons of the webinar, Dr. Prabhat Kumar Dwivedi, IIT Kanpur, and Dr. Dharmendra Pratap Singh from France. Dear participants of the webinar, dear colleagues, students, ladies and gentlemen, it's my pleasure to welcome you all this morning to the webinar on modern application of nanotechnology, its future challenges, organized by our department. As you are aware that nanotechnology is being used in almost all spheres of science today. Nanomaterials are being engineered these days as per the requirements and finding application in industry, medicine, targeted drug delivery to cure cancer-like disease, agriculture, energy challenges, and many more. Carbon nanotubes are being also developed in order to use in processes such as the addition of antibodies to the nanotubes to create bacteria sensors. Nanomaterials are class of materials with size between 1 to 100 nanometer and exhibit several peculiar optical, electrical, thermal, chemical properties as compared to their bulk counterparts. In the cosmetic industry, minerals nanoparticles such as titanium oxide are used in sunscreen due to the poor stability that conventional chemical ultraviolet protection offer in the long term. It has been also used in sport industry, baseball bats that have been made with carbon nanotube, making the bat lighter to improving their performance. We are fortunate enough to have with us the two great nanophysicists who will share their great knowledge with all of us today. It is a great opportunity to our students to learn new development in taking place time to time. I once again welcome you all in the webinar organized by our department. Thank you very much. Over to Dr. Prince.
प्रॉब्लम कर रहा है बार बीच बीच में चला जाता शुरू हो गई
Over Dr. Prince.
ये हेलो मनीष हेलो
Thank you so much, sir. Now it gives me immense pleasure to introduce Dr. Manvin sir to you all. He is long and hello. I will request to all the participants, please mute yourself. Then you will be able to hear me. Please mute yourself.
जूम में देखो पार्टिसिपेंट लाइव आ रहा है उसमें कोई
I request to all the participants, please mute yourself.
कुछ नहीं है पार्टिसिपेंट
Thank you so much, sir. Now it gives me immense pleasure to introduce our respected principal, Dr. Manvin Singh Ji, to you all. His long and memorial association of over 4 decades commenced as a student. Then he got appointed as an assistant professor of political science. Later on, he became an associate professor, and now he has been serving this institution as a principal for the last 13 years. He has been committed to the welfare of institution ever since he took over the charge. It is for this reason and many more, I would like to request him to speak a few words about the webinar. Over to you, sir.
13, 16, 17, 18, 19, 22, 23,
Hello.
24, 25, 26,
Sir, you may continue. Yes, sir. Sir, please continue, sir.
बोले ऑनरेबल सेक्रेटरी बोर्ड ऑफ मैनेजमेंट श्री ब्रह्मेंद्र स्वरूप जी, आयोजन समिति के सचिव डॉक्टर प्रिंस, डिपार्टमेंट D.S.N कॉलेज उन्नाव के हमारे एसोसिएट प्रोफेसर तथा समस्त अन्य सहयोग करने वाले हमारे सभी शिक्षक साथी, आज बड़े हर्ष का विषय है कि हमारे फिजिक्स डिपार्टमेंट के द्वारा एक नैनो टेक्नोलॉजी पर वेबिनार का आयोजन किया गया है। इस संकट काल में, कोरोना के संकट काल में भी पठन पाठन को जागृत रखने में D.S.N कॉलेज का महत्वपूर्ण योगदान रहा है। मैं सभी शिक्षकों का तहे दिल से शुक्रिया अदा करता हूं कि उन्होंने इस अपने अपने डिपार्टमेंट में वेबिनार के आयोजन के द्वारा पठन पाठन की प्रक्रिया को कोरोना जैसे संक्रमण काल में भी जागृत रखा। आज से कुछ समय पूर्व एक मानव की कल्पना भी नहीं कर सकता था कि आने वाले समय में ऐसी तकनीक विकसित की जा रही है जिसकी सहायता से स्वतः निर्णय के आधार पर कार्य करने वाले अंतरिक्ष यान या युद्ध के दौरान रासायनिक एवं जैविक हथियारों से बचाव करने वाले बायो सेंसर युक्त वस्त्र या फिर अपने विश्व भर की जानकारियां समेटे रेत के कण के आकार वाले यंत्र का निर्माण किया जा सकेगा। किंतु आज नैनो टेक्नोलॉजी ने यह सब कर दिखाया है। नैनो टेक्नोलॉजी के द्वारा चिकित्सा उपकरणों व सेंसर का निर्माण कर सैन्य क्षेत्र सहित सामान्य लोगों को भी सहायता पहुंचाई जा सकती है। पानी की सफाई करने, रासायनिक व जैविक हथियारों से त्वचा की रक्षा करने वाले वस्त्रों, ग्राफीन के प्रयोग करने वाले इलेक्ट्रॉनिक कंडक्टर, ट्रांजिस्टर आदि के निर्माण में नैनो टेक्नोलॉजी का प्रयोग हो रहा है। आज के इस वैश्विक महामारी के काल में जब विश्व चौथा तृतीय विश्व युद्ध के बादल मंडरा रहे हैं, तो अनेक देश अपने अपने आगे पीछे सेनाएं ताने हुए हैं, उस काल में नैनो टेक्नोलॉजी के अस्त्र शस्त्र बहुत अधिक उपयोगी साबित होंगे, देश की सुरक्षा में भी और देश के विकास में भी। मैं फिजिक्स डिपार्टमेंट के सारे सब मेंबर्स को बधाई देता हूं कि उन्होंने नैनो टेक्नोलॉजी जैसे गंभीर विषय पर आज एक वेबिनार का आयोजन किया है। मैं अपने मुख्य अतिथि माननीय सचिव महोदय का भी आभारी हूं कि उन्होंने कुछ समय देकर शिक्षकों का उत्साहवर्धन किया और जितने भी लोग वेबिनार में हमारे सहयोग कर रहे हैं या ऑडियंस के रूप में या पार्टिसिपेंट के रूप में सम्मिलित हुए हैं, उन सबका मैं तहे दिल से स्वागत, अभिनंदन एवं वंदन करता हूं। धन्यवाद।
Thank you so much, sir, for your kind words. Since we all are talking about nanotechnology, I want to tell a little bit about nanotechnology. Nanotechnology is defined as the study and use of structures between 1 nanometer to 100 nanometer in size. A nanometer is 1 billionth of a meter.
बस
For
ठीक है
instance,
ये चल
a
रही है साथ
sheet of paper is about
कौन की
100,000
चल रही है प्रिंस बोल रहे
nanometer
हैं
thick. Commercial products which are available in the market today,
स्मार्ट हो
like
गई
camera display, computer, eyeglass, use nanotechnology.
हम कह रहे तुम तो स्मार्ट हो गई
Better imaging and diagnostic tool enabled by nanotechnology are paving the way for earlier diagnosis. And nanotechnology has changed the way doctors treat cancer and dramatically reduce the toxic effect of chemotherapy. Thus, we can say that nanotechnology has greatly contributed to major advances in various fields like information technology, homeland security, medicine, energy, food safety, and many more. So, keeping the importance of nanotechnology in mind, we have chosen this particular topic for webinar. To explain further in greater details, we have invited two esteemed speakers, one from IIT Kanpur and the other from France. We would now start the technical session with the introduction of our first speaker. But before we go to the technical session, I would say that if you have any question during the talk, you can write your questions in your notebook, and then we will have a question and answer session. You can ask your questions in the question and answer session. And I would now like to invite Dr. Utkarsh Saxena, Assistant Professor, Department of Chemistry, D.S.N. PG College, Unnao, to formally introduce of our first speaker, who is going to speak for first session. Dr.
Okay,
Utkarsh Saxena.
thank you, Dr. Prince. Now I would like to introduce Dr. Prabhat Kumar Dwivedi, who is the resource person of this technical session. He is an experimental physicist and is presently engaged in the research field of material science and nanotechnology for the last 10 years. He obtained his PhD from Harcourt Butler Technological Institute, Kanpur, and his postdoctoral training from University of Alberta TR Labs, Edmonton, Canada. Currently, he is working as senior scientific officer at the Center of Nanosciences, Indian Institute of Technology, IIT Kanpur, India. He has substantial experience and expertise in the area of nanomaterial synthesis and characterization, electrospun polymer nanofibers, micro pattern, microfluidic, and microsystems fabrication using various lithography and electrospinning processes. His current research work focuses design and synthesis of hybrid plasmonic nanostructures, microfluidic based integrated detection platforms for infectious diseases, SERS based sensor design and fabrication. He has various awards and recognition to his credit, some of which include a fellowship from Lehigh University, USA, and KNU University, Daegu, South Korea. He has contributed various chapters and journal papers in peer-reviewed journal and conferences. He has published more than 35 peer-reviewed papers in the last 5 years. And also, he is a member of SPIE, ACS, and Soft Materials Research Society, Jaipur, India. Having introduced our resource person of this session, now I invite Dr. Prabhat Kumar Dwivedi sir to enlighten us with his scholarly talk. Over to Dr. Dwivedi sir, please.
Thank you very much. Are you getting my voice?
Yes, yes, you are audible, sir.
Yes, you are audible.
Thank you. Very good morning. Very good morning, all of you.
Good morning, sir.
So should we start? Thank you for your kind introduction.
Yes, yes, please.
So should we start the technical session?
Yes,
Yes,
we
please.
have actually 5 minutes more to start.
So basically, we are ahead from the program, right?
Yes, yes, yes.
We have to wait for a couple of minutes, right?
Hello.
We have to wait for a few minutes, or?
Yes, we can wait. We can wait, sir, for 2 to 3 minutes.
Okay.
Yes.
Can you share the link so I can share my presentation? So
Okay, okay. So, disable करा।
ये प्रिंस बहुत सारे लोगों के माइक्स डिस्टर्ब करते रहते हैं।
Pramod Kumar Rajput, sir, please mute yourself. And Chetan, sir, please mute yourself. Chetan. Pramod Kumar, sir, please mute yourself.
Please mute yourself. There is a lot of disturbance. I think Pramod Kumar is unmuted. Please mute.
Hello. Hello, sir. Please share your screen. Now you are host, sir.
Okay, sir. Let's start it, right?
Yes, yes, yes.
Okay.
Pramod Kumar, sir, please mute your mic.
Full case. ये क्या खुल गया? बैक कर दो इसको। नहीं, अच्छा उनके वो दिखाने वाला है।
Hi, Prince, it is visible to you?
Yes, yes. Now your screen is sharing.
Okay.
Yes.
So please let me know when we start.
Okay. You have sir 2 minutes more. Then I'll manage that. Nobody is mic is on. Okay, sir.
Sure.
Yes.
So let me know when we have to start it, right?
Yes.
I'm
Yes.
waiting for that.
Yes. Yes. laptop में है कि नहीं? Sir, now you can share your screen. Hello. 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 Am I audible?
You are audible, Prince. Dr. Prince.
Okay.
No,
Okay.
no, I'm Prabhat. Are you getting my voice?
Yes,
Yes.
yes, sir.
So should we start actually?
Yes. Yes. Sir. Yes. You can start, sir.
Okay. So very good morning, all of you. So initially I would like to thank the management for giving me a chance to talk about something on nanotechnology and their application. Right. So today we are going to talk about something on nanotechnology-based approaches for rapid on-site detection of biochemical markers, which could be helpful for preventive health care or capturing the environment pollution, pollutants, or many other stuff. So what I will just going to talk about, initially I would like to give you a small overview of nanotechnology. What exactly nanotechnology is, and how is useful for resolving various issues, which is challenges for the humankind, right? Then what does it mean by preventive healthcare and healthcare system in India? Then what is the new ecosystem is required for the healthcare problems in Indian scenario. So point of care based diagnostic platforms and sensors. And finally, surface enhanced Raman spectroscopy based point of care sensors devices. So this is the whole, four areas where I would like to talk in briefly. And before starting the real business, I would like to introduce Center for Nanoscience. The Center for Nanoscience is a interdisciplinary center at IIT Kanpur, established in 2008. The basic mandate of the center is to provide state-of-art facility and resources for carrying out the research and development activity in the area of nanoscience and nanotechnology. So basically, it's a world-class facility which equipped with all the resources, equipment, expertise, which is required for the carrying forward the research in the area of nanoscience and technology. So Aman Center is having a spin-off company that is called eSpin Company, and various collaborations around the globe. And so this is all about center, and those who would like to close by area, so can visit anytime to center for exploring possibility for collaboration and doing some research. So there are different modes for doing the research, either payment basis or collaboration, and many other possibilities are available at Center for Nanoscience at IIT Kanpur. So basically just a few pictures for the center where we have different labs and facilities. So these are the labs which we have at Center for Nanoscience. These are the clean room labs where we perform all the experimental things. So here you can see the tools which we have, like a very sophisticated tools which are required for doing research in the area of nanoscience or technology. So basically, we have to get a clean environment to accommodate them. So first is like characterization tools. We need various characterization tools to characterize nanomaterials, nanosystems, nanostructures, and many other things which falls in the regime of nano regime, right? So if you can see, scanning microscope, profilometer, eluxometer, near field microscopy, reactive ion etching, thermal deposition for metallization, and many other tools which are required for such activity. And second part is you can see where the equipments or tools which are needed for the fabrication. If you want to fabricate some structures or some platforms or diagnostic systems which could be useful to carry forward for the device applications. So we are well equipped, a interdisciplinary center for providing the expertise and resources as well, right? So here you can see, transmission electron microscope, Titan 300 and Techni, which can handle all the biological samples and high-end material science samples. So we can do a lot by characterizing materials at a nano level. And so these are the tools which we have for dealing all such things. So apart from having a world-class facility for nanoscience research, you all are aware about the last year we had a pandemic year and we suffered a lot of things from various activities. So what we did in last year, for the challenges for COVID-19, so we developed a facility for mask development. You are aware about the SWASA mask. So those masks are developed at IIT Kanpur in our center. So eSpin, which is a spin-off company of the center, has established a facility with the collaborations of our institute, which can produce 25,000 masks per day and 95 masks per day. And we are providing all such masks to our all frontline workers, like paramilitary forces, doctors, and many others. So we are working for the second phase of this project by bringing a antibacterial and many other sophisticated masks, and that will come in coming 2 months. That is under our investigation at Virology Lab in Pune, right? So I can show you the a small video where you can see the video. So this facility is like a huge facility which can produce 25,000 masks per day. And we employed many people from around the Kanpur who are working here to produce such thing, non-skilled labor basically. And many other, like apart from this mask, our different centers and departments just come up with high-end products such as ventilators, PP kits, sanitizers, UV-based sanitizer systems. And so we did a lot of work to serve the society during last year and come up with a very fine equipments and tools, right? So now come to the main business. So what are the challenges for human life? If you can talk about, basically I'm going to talk about mostly in Indian scenario. So basic major challenges which we are facing for our everyday life is healthcare. How to provide a better healthcare system or cheap healthcare system for everyone, particularly those who are living less resource area, or I would say remote areas, or areas where we don't have resources. Food safety is a very major important area. Like if you talk about like milk, so most of the times you see the demand for the demand for the milk is higher. During time when they match up the demand, they put some food adulterant inside. So how we can come up to find out or investigate or quantify those ingredients which are in milk or many other food items which are not good for the healthcare. Biochemical hazards or environmental contaminants, like provide a clean water. Water is contaminated with arsenic and many other nitroaromatic compounds, which is not good for health. So how we can deal such situations? So do we, nanotechnology can help us here, or what are the ways it can be? Like if you talk about the disease, basically what we have to do is we have to find a diagnostic, we have to, actually lot of noise is coming. Hello?
Yes, sir. Yes, sir.
I mean, somebody is like talking. Anyway, just let's start it. So basically, we have to develop device diagnostic platform which can use various nanotechnology components. So can we do that? Develop a device diagnostic platform at lower level side and screening, and that could provide a preventive healthcare. So what does it mean preventive healthcare? If we can just quantify the body fluids like blood, serum, or urine samples or saliva, and predict well before the disease come into the picture. Drug release system. If you can see the data for World Healthcare Organization, 70% of all types of cancer deaths are in developing countries, and we are one of them, right? So how we can deal such situations, right? So basically, we are exploring nanotechnology based systems or nanomaterials or many nano diagnostic platform where we can find a place to work out all such things. So if you can talk about, like you many heard about the Alzheimer disease is like mental disorderness, right? So once like you get it, you have to do many tests. So if you go for like RT-PCR based ELISA and major tests, which are like regular tests for this disease, the problem is, these tests require a huge volume of sample first thing, and they can diagnose the markers which are responsible for such disease when they grew up very high level. So at that time, it's really difficult to treat the Alzheimer disease. So basically, we have to get a system which can identify the responsible protein or responsible elements at very low level at early stage. So for the Alzheimer biomarker, that is a protein which called alpha beta amyloid. So can we detect beta amyloid at a very low concentration? We have to find a new diagnostic system or system which could quantify the protein at very low level. Secondly, if you talk about the liver disease, right? So I just showed you the different stages of the liver cancer. So how we can just identify the liver disease? What do you have to do? We have to go to doctor or pathological lab. We have to do some liver function test by utilizing blood as sample. Then further we can go to imaging center, which we do the ultrasound and MRI or many other things. And lastly, we have to do the biopsy. So these are the three major established technique for the liver function test, right? But these techniques are really complicated, need a lot of amount of money, and need to establish a bigger facilities which could have sophisticated tools, instrument meant for such things. So secondly, like if you talk about the disease, kidney and many other things, uric acid, you all are familiar about the blood-brain uric acid. They are the indicative systems like which can provide you. So what is the ultimate message from this slide? So basically, nanotechnology can help us to come up with solutions to provide a healthcare system at low level, low cost, and the places where we don't have facility, right? So this is the basic object of like what I'm going to talk about today. So let's see how nanotechnology can help us on this system. So I would little bit introduce the like nano microfabrication techniques which are meant to develop such platform. I'll not go in details, but I just few slides just give you like a essence of such techniques. So mostly I will talk about the sensors which can be produced by the help of nanotechnology, nanomaterials or nanosystem, which could be helpful for providing a better healthcare, right? So if I'll talk about the overview of nano microfabrication, so like the word sounds nano fabrications. So, we have to fabricate materials, systems, structures at nano level. So we have to find out the tools and methods which can produce materials at nano levels. Further, we have to visualize them. Basically, if you have created something at nano level, you have to find the equipments or tools which can be seen. Like I would say, like if you have produced a nanoparticle which is like few nanometer in diameter, or so can you see it by naked eye? No, regular microscope cannot work for that thing. So we need to have a specialized microscopes. So basically, there are three major components for nanofabrication or nanomaterials and nanotechnology. Materials deposition and synthesis methods. So they could be top down, bottom up. So we have a various tools or systems or strategies to create materials at nano level by chemical synthesis, laser ablation, electrospin, or many more methods which can produce a materials that then we have to check the quality or we have to identify the investigate the materials. So basically you have to find the shape, like whatever the nanomaterials you have created. So what is the size distribution and shape of those particles and thickness and many other properties, absorption and many properties which can give you more fundamental details about the created stuff, right? So first part is material selection, deposition, and synthesis method, which could cover top-down or bottom-up approaches. Then second thing is like you would like to make a structures. Like when you are proceeding towards the device development, you have to create structures which could be micro or nano level. So you need a specialized technique. So I would here introduce lithography. Lithography, it could be optical based lithography, ion based lithography, electron based lithography, or soft lithography, or either a combination of any of two, right? So we have to produce structures at nano micro levels. So we have to adopt such techniques to create materials. And lastly or finally, I would say whatever we have cooked and whatever we have to synthesize or prepare, we would like to investigate. So we are needing various imaging and metrology tools. That includes like electron microscope. Electron microscope, it could be a transmission or reflection mode, where we have to identify and predict about the size, shape, and many other fundamental about the synthesized materials. Then secondly, scanning probe microscope, like surface investigation, and lastly, spectroscopy. So these are the three different major components of the nano fabrication are part of nanotechnology. So material selection or deposition, creation of structures, and finally to investigate whatever we have created or synthesized it. So three major components. Just I would like to make you familiar about these words. Then how we can define about the nano patterns and nanomaterials. So earlier there was confusions, but now please keep quiet.
I request to all the participants, please mute yourself. I'm requesting again. Please mute yourself.
So how do we define the nano structures or so now there is a clear definition about the nanomaterials.
भैया चला गया। मैं तो दीपिका के पास आई थी रात को, इसको मैंने फोन करा है, अब कह रही है 10-15 मिनट लगेंगे। हाँ ज्यादा ही वाइट हो पड़े हैं ना।
Okay, so there is a clear definition for the so any dimension should be few hundreds of nanometer, right? So there are
नहीं सुबह 6 बजे
please
फोन ही करा और रात को 12 बजे आए हैं घूम घाम के।
प्रिंस इनको निकाल सकते हैं क्या?
तो बस ऐसे घुमाते रहते हैं डिनर बाहर करके और फिर सुबह 6 बजे के गए हुए हम। अब रात को जाना है ऑफिस।
प्रिंस आर यू गेटिंग?
इसलिए मैंने तो फोन ही नहीं करा। मैं
इनको हटा सकते हैं क्या? वो जिया जी की बात कर रही हैं।
Sure sir, those who are disturbing, so you can
बैठते हैं ना। मैं तो नाश्ता बिल्कुल अब करके
Other people are also not getting the
10 मिनट के लिए वापस जाऊं।
please make me as a host. I can do all these things.
Okay, just wait. I'm talking. Just I'll try to do it. Right? Just wait for a few minutes.
मैंने लक्ष्य कैसे कराऊं भाई, मैं इतने लंबे लंबे बाल हुए पड़े थे, फिर अब भेजा है और क्या करवा के नला के। पिछली बार यांशी करवा के आई थी सेटिंग इसी से खुले रखती होगी फिर मम्मी अब तैयार हुई पड़ी है करनाल जाने के लिए। कन्नू के साथ जाऊंगी। अब आएंगे लंगर पे। अच्छा तो वो तुम सूट लेके रखियो मेरे शादी के लिए। पहले मंगवाया एक, वो उसमें डाल गया अब सगन वाले दिन। अच्छा अब मेरा सूट लेके रखियो, कम से कम 5000 तक है।
हाँ सर वो पता नहीं।
अब उन्होंने 2 ले रखे हैं, कहते अब मैं वो
नहीं हो रहा था अभी तक।
मैं चली जाती हूँ उनके साथ और फिर उनके साथ आ जाऊंगी।
नहीं कुछ नहीं दिखाई दे रहा था, कोई स्लाइड आपकी दिखाई नहीं दी थी अब तक।
5500 का सूट लिया।
हाँ मुझे लगा कि आप अभी इंट्रोडक्शन
ऐसे ही
शेयर करेंगे अपनी। केवल सर आपका जो पीपीटी जहाँ पे है ना
हाँ हाँ सेम वही दिखाई दे रहा है सर, पीपीटी स्क्रीन कोई नहीं दिखाई दे रही।
Our goal. So current status, like if you talk about the top down, we are using various photolithography based techniques, electron beam, focused ion beam, dip in hello, dip in lithography and everything. So these requires a like clean room environment and many challenges for the money, right? So can we obtain high aspect ratio or many other things? So we have to evaluate these things before going for any other substitute. Second part is bottom up synthesis. I already talked about you, talked like a top down versus bottom up. So both have their own issues. So we have to be clever enough to select any of such techniques or in a particular one or two or combination of any of these two to provide a better solution or to establish a very stable process, right? For the fabrication of nanomaterials, nanostructures, which can be used further for any nano device or micro device. So basically till this point, I talked about like what exactly nanotechnologies are their major component. Now the basic issue is healthcare system in India. We are the second largest populous country in the world. So providing a healthcare on time to everyone at low resource areas, remote locations, villages, small towns is really critical and almost impossible to provide on time. So what to do now? So if you talk about the major healthcare system in India, we have like a government hospitals at big cities. Those have a specialized doctors, nurses, and infrastructure which could provide you the pharmacy and many other things like. And secondly, you have to go to small towns and villages. They have like health dispensaries. So doctor is assigned for that thing, but not a specialized doctor. And doctor is because not much infrastructure available at villages. So doctor lives in a city and visited once in a month or a week or so. So it's hard to provide on-time medical facilities to the villages or remote locations. On the other, if you talk about the healthcare system in India, we are having a lot of issues. Like if you talk the basic infrastructures. So in terms of doctors, so most of the I mean, as per the World Healthcare Organization, what exactly should be and what we are is given number here. So we have a very shortage of doctors per thousand people or paramedical staff. So what to do for that thing? Either we have to train more doctors or provide a bigger hospitals. So that is not possible immediately because of lack of infrastructure or lack of funds. So we have to get a huge fund to establish such structures. Secondly, hospitals and diagnostic centers are limited with low outreach due to locations from masses. So if you are living like 100 kilometers from Kanpur at a small village, to you got something, you have to rush to Kanpur or some major cities like Kanpur is an example. So what exactly is happening here? So healthcare system need to be developed, required a huge infrastructure. Either we have to provide infrastructure in terms of doctors, in terms of medical skilled persons or number of hospitals, or we have to explore any other ecosystem which can provide provide such things at low cost. Like if you can talk about like if you have a diabetic and liver problems, kidney malfunction, hypertension, so you have to get a proper testing facility where where you get like whether you have a diabetes or not, or you have to. So basically you need a centers which can provide you a better diagnostics. So if and these facilities, establishing these facilities required a huge money or something, which is not possible in current scene. I mean, government is not having such. Either private players should come in the picture, or we have to get some alternative. So here, what I'm going to talk about: can we develop a alternative healthcare ecosystem which can sort out all such things, right? So what it would be, right? So instead of going big hospitals, which is away from 100 kilometer, 200 kilometer from your place, can we provide a personalized device at your doorstep? So what does it mean? It means like, can we produce a healthcare devices which can be available at small places? So basically, I'm going to talk about if we can produce personalized healthcare devices more predictive in nature for the testing of biological fluid. Biological fluid, they have a different kind of biomarkers present in your body fluid, like blood, serum, or many other things. So if we can quantify those biomarkers well ahead of the disease, we can predict like what exactly we have to go. So these personalized device can you make you aware whether you have a disease. So they can qualitatively tell you the disease, then suggest you have to go to doctor. So instead of for every regions you have to rush to doctors, now you are safe till you get some indication from this thing. So what we can do is, so we are looking towards the personalized device to make system more user friendly. So in this way, what will happen? What will happen, like we have to develop a device which could be remotely connect to the city where by internet or something. So you can provide your healthcare data to a specialized doctor, and doctor can provide you better prescription and something. So we would like to investigate such thing. I can give you a better example here. Like every like the house where people are like having diabetic something, they have a glucometer. So it's like a personal healthcare device. Once you just regularly you can monitor your glucose level. If it is too high, so it means like you have to go to doctor, right? Otherwise, if it is well below the recommended numbers, you will be safe. How does it work? So basically, you have checked it like you have a controller where you have to put a stripes which has like electrode something. You put a few small amount of blood on that thing, and you get some number. So are you aware about how does this magic happens? Basically, you put a drop of blood on that stripe, and you get a number. So if it is below from your expected one, the standard one, you're happy and you can go for, you feel you have a reasons to feel happy. But if it is too high, you have to go to doctor. So basically that stripes has a specific uh, enzyme which can capture the glucose from your blood and give you indication about. So basically that enzyme is glucose oxidase, which bind the specific glucose from your blood and give you number. So can we produce such devices for many other stuff and provide a better personalized device for every region? So first we have to understand what is the point of care device or personalized device. So they should be rapid on site. What does it mean? So you basically they should be at your home or close by your premises. You don't have to go to doctor or you have to go to a pathological lab. So low amount of sample, preferably microliter should be there. No sample preparation. Like if you go to pathological lab, they have to get your blood or urine, they have to prepare it, and it should be sensitive, selective, easy to operate, doesn't require a skilled manpower. So this is the wish list for any point of care or personalized device. So we would like to have such specific things. So what are the like common technologies available in our country or abroad? Like these are the like calorimetry based, fluorescence based, luminescence, and electrochemical. So basically, you have to, what does it make calorimetry? Like you have a plasmonic nanostructures which changes color once you put some sample by size effect something. So if you go for the commercial application of the, what are the common limitations available in all such things? Basically, accuracy. Accuracy is one. So accuracy should be a one prominent aspect. Second thing is sensitivity. And most importantly, it is a per cost. Like if you have a personalized device which could come in 2000, but recurring number like the stripes or sensors which you have to use every time, if it is 5000, doesn't matter, we cannot use it. It should be like few rupees. So you buy a one time investment controller, then recurring amount which is a sensor or a stripe could be like few rupees. So you can every time check your health by investigating your body fluid or something. So we have to overcome all such shortcomings which is already available. If you talk about here, you can see like basically your sensor which is connected to a device, and that device connected to your smartphone, and a smartphone has a library of your biomarkers. So once you put your sample, you get some spectra or some numbers, and you can match with that library. So if it is a below red level, it means you are safe and you are comfortable. You don't have any issues to go further. So basically, we are here proposing a surface enhanced Raman spectroscopy based sensitive, highly selective device which can handle multiple analytes on a single platform. Like I talked about few like cheap healthcare, environment, food safety data, and biochem. So can we handle all such markers, even it is bio or even it is biochemical or some environment markers on a single platform? So we are trying to develop SERS based devices which could handle all such things at a lower cost. That's our basic theme of the day. So what we have to do is here to develop such things. So we have to develop a low cost flexible metallic and plasmonic hybrid substrate or sensors. What does it mean? We have to produce selectively low cost strategies or methods or processes which can provide plasmonic nanostructures. Plasmonic nano, basically they come from the gold nanomaterials, silver nanomaterials or nanostructures. So we have to use various micro or nano fabrication technologies to come up with all such plasmonic structures. Further, various biomarkers, we have to identify or quantify them and produce a library. Like if you talk about the uric acid, the uric acid give you the problem like you have a pain in your knee or your kidney has some issues or liver functions has some issues, albumin, creatinine, like creatinine give you indication about your kidney. So we have to get all such biomarkers and prepare. Further, you have to integrate all such things in a microfluidic based system, which would be portable and a miniaturized device, which you can take to like remote locations and do all such things. So selective quantification of biofluids or biochemical materials with portable Raman spectroscopy. So all such things can solve your issues which is related to biomedical, environment, chemical warfare, forensic, and food adulterants. So this is goal which we have mind to provide a device. So how we can solve those things? So first thing I will talk about what exactly surface Raman enhancement spectroscopy is. So survey is a spectroscopic technique that utilize unique molecular vibration fingerprint to identify and quantify down to ultra trace level. And it is a multiplex sensing at low concentration with a high degree of specificity. So what are the approaches we are following? So basically what is targeted chemical captures of analysis? What does it mean? So basically we are talking about the plasmonic nanostructures. We have to bring the strategies and systems where we can bring down the analytes. Analytes means your biomarker chemical in the vicinity of the nanostructure. So we have to do various strategies to bring them down. So in next slide, I would like to tell you what exactly it is. Most of you guys should be familiar about the Raman spectroscopy. It is invented in India, and so you are basically the energy of a vibrational mode depends on the molecular structure and environment, right? So you have to take Raman spectra of different molecules has unique, and Raman spectra is different for all. The issue is like Raman intensity are almost, or you can say Raman cross section is very low for something. But if you can put a metal nanostructures and absorb analyte on top the, so that is called surface Raman enhancement is cutting. So you can see how normal Raman, a surface enhanced Raman spectroscopy is different from the normal Raman. So I can give you more detailed picture about this. How does SERS work? So if you can see the extreme right, you can see two gold nanoparticles, right? And there is a mark like 1, 2, 3. So what does it picture says? So you have a combination of nanostructures which are in orderly array. So and apart from like few nanometers. So if I would say the situation 1, which is a normal one. So if you can say there is a dotted lines and that analyte or any whatever the analyte you can say is away from that pattern line. Does it mean like it is normal Raman? As soon as you bring that analyte close to the gold nanoparticle, you can see your spectra is little bit up. So number of photons coming or intensity of Raman is going up. As soon as finally you see situation 3 arises, where your analyte comes in the gap of two different gold nanoparticle. You can see the number 3 where I have put. So it is well between the two, and you have see the electromagnetic field is enhanced, and you can see in your Raman spectra your high intensity peaks are getting. How does this happens, right? So we have to, the situation 3 is called once your analyte comes in vicinity of gap of these two nanoparticles, that particular situation is called hotspot generation. So basically, for getting a better intensity at a low level of analyte, we have to develop nanoparticles, nanostructures, which could be in a arranged manner and having distance from each other less than 10 nanometer, right? So I'm not going to talk about much more on theoretical part. You can see if you have a single molecule and you have a two molecule close, how does the enhancement factors goes up from 5 orders magnitude more as compared to a single molecule. So this is all about the Raman mechanism. So what does it see? There are two different mechanisms which are responsible for the Raman spectra, Raman enhancement. One is electromagnetic enhancement, and second one is chemical enhancement. So basically, electromagnetic originate from the local electric field due to surface LSPR or SPR or metallic resonance, and chemical contributes from the charge transfer between the SERS active substrate and the molecule of choice absorbed on the surface. So we have to prepare a sensor which could have all these two features in it, and on top of that it should be reusable, reproducible, and stable during the measurement, and further can be integrated with the microfluidic chip. So we have to prepare all such SERS based sensors to investigate the various biomarkers or chemical markers. Little bit more elaborate theoretical understanding about how SERS enhancement can work. You can see there's two components like electromagnetic enhancement or chemical enhancement. So basically electromagnetic enhancement comprise localized surface plasma resonance. So you have to work out frequency of plasmonic oscillation resonance with frequency of, so what does it mean? So you have a free electrons and you put the light on it, frequency changes and just give you a resonance, and number of hot spot comes in picture. I just talked about the here, you can see the hot spot here. The hot spot basically situation 3, between the two gold nanoparticles, right? So we have to develop such strategies to get more number of hotspot to get a better intensity of. Secondly, you have to get a chemical enhancement. So basically, you have to bring down the analyte or the material which you are going to investigate in close vicinity of the metal nanoparticles, right? So you have to do many various strategies. So we have to develop sensor which could have like a signal enhancement in both ways to get a maximize the intensity, right? Now, how the various strategies are going to exploit. So I'm just showing you three different situations: high affinity to nanoparticles. Like you have a biomarker or a chemical marker or biochemical marker, which could have like very high affinity to the metal nanoparticles. So that particular case, what will happen? You have a array of metal nanoparticles. Directly, you can immobilize on them and get a signal of that thing. But in the second situation, when you have a biomolecule or something which are bigger in size, cannot go much closer to the, and secondly, they are less sensitive for the nanoparticles. What you have to do in that case? You have to generate a situation called host. So basically, you have to attach a host on each nanoparticle, which can accommodate the molecule which you are going to test. And last, you have to anchor, you have to provide an anchoring element on the gold nanoparticle, which can capture the molecule which you are going to investigate. So there are three different strategies to encounter for all this. So I'll talk about the few examples which we have already done in our lab to find the. So till this point, like I talked about like major healthcare system in India and how we can make it better in terms of personalized devices. So how that personalized devices can be created with the help of nanotechnology. And we have done, we are focusing on SERS based nanotechnology, sensing devices. And I talked about like various strategies and basic principle and mechanism of this SCRs. Now, whatever the things we have done, so I'm just going to talk about the few nano engineered platform which already developed at lab. And so we have just worked three different platforms, which is like chemically synthesized, or we have used micro patterning. So our third one is a flexible substrate, means like nanofiber mat, which is functionalized with a gold nanoparticle. And we have investigated various bio components and explosives, like you say, DNT or TNT, or a very explosive element which could be harmful for various strategic purposes, like and uric acid, which is a marker for various diseases. So I'll just go through one by one, and I'm not going much on detail, just give you the brief introduction, like how we can, how we have done that thing. To first approach which we have done for achieving a SCRS-based device or sensors. So what we have done here, we have gone through a hybrid system which is called graphene oxide, reduced graphene oxide, which is combined with metal nanoparticles. So in this approach, what we have done, we have developed a synthesized graphene oxide, then further reduced graphene oxide, and have taken AgNO3 to reduce to get a uniform distribution of silver nanoparticle on top of in the matrix of graphene oxide. And further, this hybrid nanomaterial has been used to investigate different markers like dyes, rhodamine R6, DNT, and MBA, and just develop. So here, like you can see the few results, like you can see, like we have synthesized the geo and characterized by various tools to investigate by structural or FTIR and many other things, and confirm that the developed geo graphene oxide or RGO is like few layers and something. And then further, the material has been functionalized with the gold silver nanoparticle. You can see the HRTM pictures, which can clearly show the uniform distribution of metallic nanoparticle on graphene sheet. They have a spherical nature, and average particle size varies from 40 to 45 nanometers, which could be good enough to provide a enhanced surface activity. And these synthesized nano composites has been used for the detection of this thing. And you can see we have got like 5 orders of enhancement for like, I mean, that is quite good to get the system working, right? So simply, I would say we have synthesized a chemically synthesized silver nanoparticles well distributed on graphene sheet. So what does it mean here? Graphene is providing a chemical charge transfer, and silver nanoparticle is providing. So this enhancement is due to the combination of electromagnetics as well as chemical transfer. And second approach which we are using in our lab is like a micro patterning. So what we are going to do is here, we have a silver sheet or gold metal sheet, and we are using femtosecond laser to evaluate this. So we are using in 3 different approaches, like the parameters which can influence the creation of nanoparticles or nanostructures. So what we are doing here, we are going in a linear patterns or cross patterns. So idea behind is we have to get a uniform distribution of metal nanoparticles in a full covered area. If you can see linearly, these big lines are like there. So basically each ablated lines has 100 nanometer in between, and the similar thing. And further, these nano patterned systems has been used for the various diagnostic platform, right? So what exactly is happening here? So we have taken a silver sheet. You can see in picture A, the plain sheet, which is before ablation. We have taken the same pictures, and finally further that has been used for 3 different energies, 25 microjoule, 50 microjoules. And so whole idea is to develop and optimize a system where we can get a uniform distribution of metal nanoparticles on a simple platform. So for that, we have done all such experiment, and you see the propylomer data. I mean, so basically what is happening here? So we are getting a hierarchical structure of nanoparticles, which could be, I mean, by ablating its different doses, a rapid increase in ablation rate. So as soon as you increase the intensity, the particle sizes, ablation rate is going to up, but you have to optimize the required size and shape of the particle, right? So we have to optimize something. The optimization has been done here. You can further, like we have investigated it like for various 2,4-dinitrotoluene as a analyte, and we found like a better enhancement for sensitivity up to picomolar sensitivity has been achieved. And finally, what we are going to do is here, if you can see the picture, so we are putting these sensors, which is a hybrid nature, which is a hybrid in nature, like a combination of metal nanoparticle with graphene oxide, and that sensor has been put it in a microfluidic environment and put on, and that can be taken to anywhere in a field, and by applying or implying a portable Raman, you can detect such explosive molecules on-site detection kind. So this is the like a second approach which we have done. And in the second approach, apart from linear ablation, we have used, like if you can see the linear ablation and cross. So what does it mean? Basically, we were trying to optimize the morphological structures of silver or gold nanoparticles to get a better favorable conditions for the SCRS enhancement. So you can see like the linear and cross patterns, we have average particle size, which we have to go obtained is 60 to 70 nanometer in a linear one, and 30 to 40 nanometer in a cross pattern. And we have achieved a uniform distribution, in a more uniform distribution in cross pattern system. And further, these systems has been used for the detection of various components like DPA, which is a dipicolonic acid. So dipicolonic acid, a biomarker for anthrax. You are aware about the anthrax, like if you are, that is a bacteria and food. So what does it mean? So such bacteria has like 15 to 20% weight of acid, which is called dipechloric acid. So if you can identify the dipechloric acid, it sounds like you are somewhere is the anthrax bacteria there. Then further we have used picric acid and DNT. So picric acid is a nitroaromatic compound which normally contaminate the water. So which makes like water is not usable. So we have chosen these three biohazardous material and obtained a really impressive sensitivity out of these developed sensors, right? Further, what we have done, we have used the possibility whether we can use the developed sensor reusable. So we have done the test by just done the test and then washed and done the test, and after 4 cycles there is not much change in intensity of Raman spectrum. So almost 95% intensity has been achieved after 4th cycle, which is comparable to first one, right? And then we have just examined reproducibility. So we have checked like various sets of experiment, and we found and we have obtained the RSD of each system. So it's almost better to say like almost the similar intensity which you can see the pictures or quantitatively. So what does it mean? So we have developed a sensor which can be used for the detection of any specific biochemical markers, right? So we have done here like dipechloric acid or DNT or picric acid. These are like nitroaromatic compounds and a biomarker, and achieved a LOD of up to femtomolar sensor, which is well addressed by our system. If we also compare all such things by the different approach, the studies has been done by different approaches, and we found after benchmarking we are better placed. So we are trying to make a complete device to explore to quantify, selectively quantify all such elements on on-site detection. And lastly, the third approach which we are using here is a nanofibers mat based system, which is further functionalized with so nano spinning or electro spinning is a technique where you can produce a polymeric nanofibers by applying. So we have optimized various polymers to produce. So basically your polymer should be biocompatible, many other things. So I'm not going to talk about here. So only just what I'm going to talk about here. This is the schematic of the system which we have used for the development of nanofibers. And further, those nanofibers mat has been functionalized with the schemes to prepare a linker. So it could be a covalent or host. So I just initially talked about there are 3 different mechanisms to capture the molecule on top of the plasmonic nanostructure. Either it should be directly prone to attach with the nanoparticles, metal nanoparticles, or you have to anchor something. So what we did it here, we have prepared a system which is a pan-derived nanofibers, and further we have to put a purine derivatives which is a adenine, which acts as a anchor to attach the gold nanoparticles. So if you can see it here, the first picture, the matrix is pan nanofibers which adenine sites, and secondly, in second picture you can see the most of the gold nanoparticles are sitting on adenine site by thiol capturing, and third we have put a uric acid, which is a biomarker for to understand the kidney function or liver function or many other diseases which can be. So this is the system which we have used to produce the sensors. So what we have got, you can see the first picture shows like nanofibers which has like a combination of pan and adenine in the first ABCD pictures, different magnitudes. Then further these pictures has been incorporated with different L. L is what? L is a anchoring group. So basically you can see there's 4 different set of samples, P1, P2, P3 and P4, which is having like a different amount of adenine. So P1 it don't have like adenine, and P2, P3 and different. So P4 is having high amount of adenine, which is anchoring group. You can see from our HERTM pictures, you can see the clear fibers mat have a gold nanoparticle stick on top of that thing, which can produce a many hot spot, which can generate many hot spot to produce a high amount of intensity to get a better SCRS sensor. What is the result behind it? So we have gone through the different concentration of uric acid to identify that thing, and we have achieved up to 10 to the power -7 kind of a mole sensitive section, which is well.
देखो पहले चालू करो है तो का वीडियो क्या
Hello.
बंद करूं
Hello.
Yes, sir. Yes, sir. Please.
Yeah. Can I carry on? Yeah.
Yes, sir.
So you can see the Raman spectra. So I'm not going here. You can see we have calculated limit of detection, enhancement factor, or many other. So we have simply achieved a detection limit, or a limit of detection, which is 100 nanometer, 100 nanomolar, and it is well better to if you compare all the other systems like available for the detection of uric acid. So I would say such kind of sensor easily can be deployed to various remote locations, which can measure the bio markers, right? So the last approach which we are working is a paper-based CRS chip. So what we are having here, we have a simple filter paper, and that is further functionalized with gold or silver nanoparticle, whatever you are looking for any. So either you can in situ develop a gold nanoparticle or silver nanoparticle, or you can develop separately and pipetting on top of that thing. Further, you can investigate the morphological studies of all such developed things, and finally you can use them for SCRS measurement for identity. So this could be like a flexible. Flexible is like you can, the flexible substrate, like, right? So here the different approach which we are working is, so what we are doing is here, so we have demonstrated like most of the time if you just go in summers, like, so lot of contaminants like urea or melamine, people are mixing it in milk, right? So basically urea gives you the better fats, and melamine gives, urea gives you the stability, and melamine gives you the like fat contents, like. So once you boil it, you can see a lot of cream is coming on, like हम हिंदी में बोलते हैं बहुत सारा मलाई आ गया, but that is not real thing, that is coming from the melamine. And we are happy, like, and melamine is not cannot be dissolved inside, that is a hard is a not good material for your health, right? And W World Healthcare or standardized a amount which is like fixed, and a lot of people in our basically in our cities, we are getting a huge amount of melamine. So how we detect that thing? So we already have a paper-based sensor which can investigate or quantify, identify melamine or urea, which is not good for health, right? So basically, I have talked this point like different types of sensors which has been developed by us based on SCRS senses, and those developed the sensors means nanomaterial combination of metal with graphene oxide and zinc oxide and many other things. Further, they have been employed in a microfluidic environment to use them as a portable. So we are giving a name to our sensors, which is called Swasth Sarathi. Swasth means like your health. Sarathi means which navigate your things, a portable device for healthcare. Right? So this is the whole exercise to come up with a device. So where we are currently. So we have developed various strategical techniques which can fulfill task one. So task one is what? Design and fabrication of flexible substrate using electrospinning, functionalized. So we have done this part. So we are well established getting nanoparticles, nanostructures with a combination of various other materials, hybrid nanomaterials. Further, those materials has been used to investigate RP testing with body fluids, calibration or something. And third task is to create a microfluidic based device which can accommodate all such sensors for the field deployable. So we already have done part 1, part 2, part 3, and we are almost about to complete the task 4 to come up with a solution of a complete device. And very soon we are hoping to get a complete device which could be helpful for the preventive healthcare for rural areas. So what is it? Probably it would be having a box which can be portable. You can take it anywhere in this, and it could be having a sensor. So sensor can be kept inside the microfluidic chamber, and you have to apply a portable Raman system and get the spectra done. So and then you hook up with some computer or like a mobile phone where already they would be having a library. So whatever the spectra you are getting can be matches with the library, and you can predict the safe amount of that thing. So you match the spectra first thing. Once you match the spectra, then you can say the amount which are reflecting by the spectra is a prone to disease or not. So simply it can say, you have, like I would say, if you have a uric acid level up, that means that device can tell you have to consult to doctor. If your uric acid is less than the standard number, so probably that would not be reason to go to doctor. So simply this device can be used as a preventive healthcare measure. Preventive healthcare means like, so any biomarker available in your samples like a fluid, any body fluid like a, blood, serum or something could indicate, could capture like a markers which is responsible for disease and tell you whether you are prone to have that disease or not and advise you to go to doctor. So it means regular healthcare checking can provide you the better quality of life, right? Better quality of healthcare, right? This is the whole about the today's talk, like, and you can see the different papers we have recently got from last 2 years talking about all such activities covering it's from 2019 to 20. We have got 4-5 papers. These are the old ones. We have got a couple of more papers and one patent which I talked about. So we are patenting our this Swasth Sarthi kind of stuff to come bring it down to market. So here, like basically what we are trying to do is we are trying to make a I'm telling you the one interesting story. If you can see, I just forget to put the graph. Like if you talk about the 2020 April or May, like we were doing the COVID testing, right? And that number was very slow. We have achieved a very small number after 6 months. What was the reason behind? Reason behind was that like most of the kits which we were using for the detection of like a COVID test, they were coming from abroad and we were not manufacturing them in India. That was the reason we were depending on the different nations to bring down the so we have to put a lot of emphasis or efforts to make such devices in our in-house in India, and that's for vocal for local, make in India. Thank you very much. So I would be happy to have any questions or something. So if I would summarize like what was the takeaway message from this talk. So that was like we are trying to develop a sensors or devices which could be which could quantify or qualitatively or body fluid or explosives or many other things, right? And provide a better healthcare to every citizens of India.
Thank you so much,
So
sir.
I'm done for that.
Thank you so much, sir. It was indeed a very informative talk. Now the session is open for question and answer. If you have any questions, you can write your questions in chat box, or you can raise your virtual hand, and when I can give you chance to ask. If anyone has any question, please raise your virtual hand or write your question in chat box. I don't think, sir, there is any questions, but I have a question in mind that
Yeah, please carry on.
yes, sir. So suppose anyone is suffering from cancer. So is there uh, any role of nanotechnology to detect earlier of an cancer?
Yeah, actually, yes. So see, what is happening here? Like I am giving you one example, like Alzheimer
Yeah.
or cancer, or if you talk about dengue. So what is happening here in dengue? So basically, among the responsible pathogen, which is responsible for the dengue, you are not able to detect as a lower amount of the earlier because of for the established techniques which are available, RT-PCR and many other things, they required a huge volume of the sample, right? So once you get a huge amount of that thing, at that time your cancer or dengue goes up and you cannot control it, right? So basically, I would, if you are talking about the cancerous cell, so basically nanotechnology can help you by different ways. First is like a screening. So you have to develop a equipment like SER or something which can screen various patient or possible patient for such things. Second thing is you have to provide a drug mostly like now just the techniques available. If we can get targeted drug delivery, which can be make happen by using nanotechnology on a spot where you are needing to kill the bad cells, right? So certainly nanotechnology or nano drugs can help to prevent such things.
Okay, it means that our scientists are doing in this field. So, is there any?
Lot of work is already in progress, and they are theoretically or like I mean they have to come up a device. I mean I would say like there is three stages. One is like you have to develop a concept and then material or systems that has been done. Secondly, you have to investigate with very patient on some that has been, but ultimately you have to come up with a box or you can say device. So there we are little lacking, and we have to come forward to establish and create those devices to put it in the market. And that's why a lot of startups and scientific we are developing companies to bring it down to like eSpin. eSpin company is a spin-off company of Nanosensor, right? So they are producing many like devices based on such thing, right? So we have to make sure like all such startups and will come up and produce a great idea to bring such devices in a public domain.
Okay, thank you so much, sir. Is
Thank yeah.
once again I'm asking, is there any questions? Otherwise, okay.
So I guess there is no question. So Prince, I'm going to quit it, right?
Okay, sir. Sir, let me give you a vote of thanks. Then you can quit. So, on behalf of all the participants and all organizing team, I would like to thank you for your very informative talk. You told about the fabrication of Swasth Sarthi, a portable device for healthcare. Uh, so thank you once again, sir. You give your valuable time. Thank you once again, sir.
So thanks, thanks. You did a well done job to bring all such people on board to understand and such things. Thank you again.
Thank you.
So you are going to invite Dharmen now, right?
Yes, yes, yes.
Okay,
So,
carry on.
okay.
Have a nice time.
With this, we come to the end of the first technical session. Now we begin with the second session. For that, I would like to invite Dr. Hemen Singh sir Associate Professor, Department of Chemistry, D.S.N. PG College, Unnao, for formally introduce our second speaker. Over to you, sir.
Thank you, Prince, Dr. Prince. Good afternoon. I formally welcome you all in the second session of this webinar. The speaker for this session is Dr. Dharmendra Pratap Singh, currently working as Associate Professor in University of Littoral, Opal Coast, France. He completed his PhD under the supervision of Professor Rajiv Manohar at Liquid Crystal Research Laboratory, Department of Physics, University of India in 2016. He has also worked as Senior Research Fellow in the Department of Physics, Lucknow University, Lucknow. His areas of interest are thermotropic and lyotropic liquid crystals, liquid crystals, nanomaterial, composite to systems, graphene oxide, reduced graphene oxide, quantum dots oxide, sulfide nanoparticles, ionic liquids, photovoltaic applications, optoelectronic and electro-optic devices, including applications in electronic optics. He has published more than 90 research articles in internationally indexed journals. He has also been awarded by Young Researcher in 2012 by Indian Liquid Crystal Society, SPIE, Early Career Award in ICAMP 2013 at Cambridge University, UK. He has also been awarded by prestigious Raman Charpak Fellowship, a doctoral student exchange program between India and France in 2014. He is also recipient of Liquid Crystals Beauty Artist of July 2015. He has won Best Paper Award at IMIT 2015 at Daegu, South Korea by Korean Information Display Society. He is also awarded by ISCA Young Scientist Award by Indian Science Congress in 2017. So without further delay, I would like to welcome Dr. Dharmendra Pratap Singh to deliver his informative talk. Thank you.
Thank you, Dr. Hemant Singh. Thank you for your kind and nice introduction. Before I begin my talk, I would like to thank Dr. Prince, who is the convener of this webinar. Thank you, Prince, for inviting me for this webinar. And it's my pleasure that me and Prince, we are childhood friends. We studied together until the bachelor's. And it's my pleasure that today he's organized one conference in his college, and I could see plenty of participants in this webinar. It's really pleasant to see. I say good afternoon to all participants. I really welcome Dr. Prabhat Dwivedi. Really, it's very nice to hear his very marvelous talk over the nanotechnology. So basically, nanotechnology is not my principal domain, but as a like subdomain, I am working with the nanotechnology. During my PhD, I work on liquid crystals. So basically, today I am not going to present like plenty of my research work here, but as there was a theme of this conference on the nanotechnology. So basically, I will present one industrial applications which nanotechnology is covering over the display industry. So I am going to share my screen now. Okay. Is it visible for all?
Yes, yes.
Okay. Okay. So here we go. Once again, I thank all the audience, all the member of the webinar organizing committee. So today I'm going to talk about the synergy of the nanotechnology and the display industry. In the morning session, you heard a marvelous lecture by Dr. Prabhat Dwivedi, who talked about different aspects of different aspects of nanotechnology, like metal nanoparticle, semiconducting nanoparticle, metal oxide nanoparticle, and so on. And their utilization in healthcare that is really very effective. And nowadays, with the help of nanotechnology, you can detect almost all type of diseases or the early stage. And I am happy to see the work what he and his team is doing at present at the IIT Kanpur. So basically, like I have designed my talk or the following outlines. I will briefly describe you what are the LCDs. So basically, these are the display devices. So today I will include the progress of liquid crystal displays, which is currently going on, and how nanotechnology has influenced the display industry, and how this nanotechnology is useful as a fundamental tool to enhance our display devices in near future. So I will briefly cover the history, how different display devices are working on, what the technology has been used, and what is the future of the display technology and display industry. So before I want to give a brief introduction where I am. So in France, I am presently at the city called Calais. It is a northern city which is close to England, and you can see very beautiful panoramic views of my city. So my city is just connected with the English Channel, and beyond that English Channel there is England. And this is a famous place from where a sea tunnel beneath the sea which goes to England, and its length is about 33 kilometers. So it's one of the important point for the sea route trade. So basically, I am associated with the University of the Littoral Opal Coast, and with the university, I am associated with the UDSM laboratory. So basically, as you know, the name of my university, that's Littoral Opal Coast University. So this is a coastal cities, and it have like 5 branches over different cities situated over this. So basically, principal cities are these: Calais and Dunkirk, and Saint-Omer, Boulogne-sur-Mer, and Weimar. One more branch is here. So basically, I am associated to 3 places. Calais, where I am doing my research work; at Dunkirk, where my second laboratory is there. And my teaching institute, I'm associated with the École d'Ingénieur, that is the engineering school of this university. So I'm associated in Calais as well as in another city called Saint-Omer. So before I proceed, I would like to thank my PhD students who are working, and without their help, it is not possible to deliver the talk. And I am really thankful for their hard work. So currently, one PhD student, Asmita Shah, she is carrying out one PhD on the topic of photovoltaics, but unfortunately, I will not cover this topic here. And this year, another student joined, Vinso, as a PhD student, where where he will be working on the energy storage aspects of the liquid crystalline molecules. So we are planning to design some new liquid crystal molecules to store the organic energies. And recently I welcome to Sukanya to my team, who won the Charpak Fellowship for the internship with me, and just before 2 weeks she joined our group. So I would like to thank my colleagues in this team also. This team is headed by Professor Christian Logo, and 2 other Professor Abdullah Daudi and Radwan Duali. 4 more assistant and associate professor, including Fridi, Yahya, Frederick, and Nicola, including me, and 2 research engineers, Patrick and Benoit. So it was a brief introduction, and now I will start over the topic. So what is the first reflex action of our mind when we hear the word liquid crystal? So when we hear it, liquid crystal, only 2 things comes in our mind: the mobile screen. All of you have a smartphone in your pocket. And second, the liquid crystal display, like television, which you have at your own home. So basically, what is the display? So you have seen plenty of displays. You have seen a CRT screen, and now the CRT screen to the foldable displays and Okay, so basically an display device is electrically operated device that shows pictures and text on their screen. So you can have the gadgets, you can have smartwatches, you have television and so on. So you can see the picture, text and so on. So it also combines the several hardware interfaces which together render the audio and video visuals. So display device is a combination of many electronic components, and it's a really fantastic because this is now it's an important part of life, and we cannot assume even our life without the display devices. So here are some example of the modern displays. So basically a lot of research has been done, and even when I was doing my PhD, I was also working on enhancing the display parameters and working on the transparent and foldable displays at that time. So basically these are the recent advancement of the curved displays. So basically at the moment, curved mobile displays are available. In addition to these curved mobile displays, scientists got a great achievement in developing the transparent displays, because when it is not on, you can see these are transparent, you can see to the other side beyond these displays. And in addition to this, they also discovered the curved displays. So basically Samsung and LG, they are two leading display companies which are based on the South Korea. So they are really working great on the field of display devices. So basically Samsung and LG, they are developing very interesting devices. So recently LG developed the curved television for different purposes. For example, if the shape of house or office is a curve, like in towers and so on, you need display devices of shape curve. So it is really important to develop different shapes of the display devices. So it's a really fantastic that a display industry is continuously progressing over fabricating the different shapes and different advancement in the display features. So basically today I am not going to present what research we are doing at current, but rather than I would like to present the display devices and how nanotechnology has influenced the display industry. So basically recently we have submitted one book chapter in Elsevier, and which will be releasing in June 2020. So we wrote a book called Quantum Dots for Modern Display Devices with my two friends, one Dr. Sudesh Gupta, who is an assistant professor at DBS College Kanpur, and second my friend who Dr. Pawan Kumar from the University of Calgary, Canada. So I will be covering some of the aspects which I have already covered in this book chapter. So for more details, you can consult with this chapter, which will be releasing in June 2021. So it's really fantastic to see the journey of displays because I and same as people, we are the evidence from the development of display industry, from the CRT screen to the now foldable displays as well. So basically this is the journey of the various kind of displays that was started from the monochromatic CRT screen, and then it converted into the color CRT screen, and further it tends like development of the twist pneumatic LCDs, as well as the TFT LCDs, OLED devices, USD devices, curved USD devices, OLED, QLED, and at the last, the foldable displays as well. So here I will give you a brief introduction and more information about the display evolution. So you know already that the first CRT screens were the first display devices, and in the beginning they were the monochromatic, like they were the black and white. So the first demonstration of the CRT took place in 1897, and it was the commercially available in 1922. So because when a scientist and engineer come together with a new technology, it takes time when it comes to the market. And when it comes to the market, then you know only the hard work of scientific community and engineers, what they have done in last many years. So in the beginning, it was a black and white. And basically, these monochrome CRTs were used in oscilloscopes and black and white televisions. So basically, you know the principle of this CRT screen, because what happens when we project the electrons via using an electron gun or a phosphor coated screen, so you can see the different type of images and text over these CRT screens. And later on, like about 30 years, the color CRT screen came into the market. And you know, the first computer screens, they were like color CRT screens. Okay, and these color CRTs, they served our society almost half century, and later on they were replaced by the LCDs. So before LCDs came into the market, and it took a like major part of the society. Before that, split flap and flip disk displays were there in market, and it was from 1957 to 1961. So basically, these flip disk displays, they are like flip dot displays. Okay. And basically their concept is they are dot matrix displays, like you do dot matrix printer and so on. Now you can print it. And basically these are the electromechanical displays. So basically, if you see the old pictures, they were used for giving the information of arrival and departure over the railway stations. So basically they were used first time in Europe and in North American countries. So basically here I have accumulated 3 pictures in which like the first image was used in the railway station at Germany. Second was it was used in the Czech Republic to demonstrate the information for the trams and buses. And the second also like departure boards at the public transport station at that Germany. So basically after these flip displays, only monochrome plasma displays came into existence. And it was done in Urbana University. It was Donald and the group of Slot and Robert who discovered this monochrome plasma display. So basically they developed this type of screen for Plato computer system. And till that, a lot of evolution has been done, and a lot of advancement has also been done in plasma displays. So basically here you can see the construction of a plasma display. So this is the front plate glass, and after that there is a dielectric layers. And after that, the display electrodes. After display electrode, there are the phosphor coating plasma cells. After that, there is pixels and the address electrode, dielectric layer again, and rare plate glass. So this is a typical construction of plasma displays. So basically, why plasma displays were important at that time? Because they possess a very high contrast ratio. And it was very, very good, even as compared to the LCDs as one. But later on, like this plasma display, even this contrast were overcome by the OLED devices. So nowadays, like OLED devices, they have more contrast than these plasma displays. So before LCD came into the market and existence, it replaced previously all type of displays, but there were 2 intermediate display phase they came before the LCDs. So first was in a vacuum fluorescent display for consumer electronics. So in the small gadget panels, you can see this type of displays, which was developed in 1967. And later on, some LEDs were utilized in the displays. That was done in 1968. And after 1968, it took the discovery of liquid crystal based displays. So liquid crystal was developed in 1988 in the Charles University at Prague. And after that, like successive discoveries and investigation over the all European country, including some part of India as well. And in 1971, the first twisted pneumatic liquid crystal display came into existence. It was developed in the Switzerland. So why LCDs are preferred over the CRT displays? You know already, when you had a black and white or colored CRT screen, big TV at your home, and when these LCDs came into the market, very soon your CRT screens and displays were replaced by these LCDs at your home. So there are 5 factors which are very, very advantageous over the CRT displays. First of all, the smaller size, because LCD occupy very, very less size as compared to 60% lesser than the CRT screen. So one of the factor was the smaller size, and second was the low power consumption, because LCDs typically consume about half the power and emit much less heat as compared to the CRT screen, because CRT screen, it was the tungsten based technology where it was using the ionic lamps, so it was consuming a lot of energy. But when LCDs came into the market, they replaced these CRT screens. Lighter weight was one of the other factors to be adopted by the society. And one more important thing is the no electromagnetic field. LCD doesn't emit any electromagnetic field and are not susceptible to them. So there are various fields where the performance of CRT displays were affected by the electromagnetic radiation and presence of electromagnetic radiance. So LCD was very significantly used where that CRT could not be used. And one of the other factor was the longer life, because when the life of these tubes and other things of the CRT screens, when they shut down, its life is over. But LCDs have the higher and longer life as compared to the CRT screen. So here I put 2 pictures, because if you remember, like maybe old people like me, they could know it. When we first time saw the Ramayana or the CRT based displays, and when we see after some time this same Ramayana over the LCD screen, the quality of everything was much improved. So it was really nice to see our favorite programs over the LCD screens. So now it's a very important and curious question, that what are liquid crystals? If we talk about the liquid crystal displays, then we must know what is liquid crystal. So basically, you all of have studied in your bachelor's that any material have 3 states of matter, that is crystal, okay, like you can say solid, liquid and gas, okay. In solid, liquid and gas, in solid and between liquid, you can differentiate that there are some crystal and the isotropic. So basically these are the solid material in which like all the atoms or molecules are well arranged in a particular way, orientation or geometry, and you can differentiate, you can define the order or orientation of on behalf of the crystallography. And isotropic liquids are, they don't possess any order at all. They are randomly distributed, all the molecules and atoms. So liquid crystals are the compound which possess like intermediate property of the crystalline solids and isotropic liquids. So basically in between isotropic liquid and crystalline solid, you can have different mesophases. Why we say mesophases to liquid crystal? Because mesophase means intermediate properties. Okay, so these liquid crystal compounds or molecules, they possess the orientation or ordering like crystal materials, but lesser than the crystals, and fluidity like the isotropic, because they have fluidity, they have viscosity and so on. So basically in liquid crystal, 3 type of phases are very important. And for nematic, SMA is schematic R, and this is schematic C. So basically these nematic liquid crystal, you can see these molecules. So they all molecules, they have a preferred orientation direction, and this preferred orientation direction is known as the director. And in schematic C, here it is important to notice they have only orientation order. But when there is a schematic A phase, you can see here they have the orientation as well as a weak positional order as well, because the molecules are arranged in the layers. You can see the layers here, and in that the director is parallel to the layer normal. And in the schematic C, your director is tilt with an angle theta with respect to layer normal. So various type of liquid crystalline phases are possible, and on behalf of the geometry and phase properties, they are used in different type of applications. So this is very beautiful phase, because we can identify, we can see this phase using a polarized optical microscopy. So when we put our sample in between a polarizer and analyzer, and we illuminate light from in reflected way or transmitted way, we can observe a beautiful color, a beautiful and colorful optical texture. So these optical texture are visible due to the birefringence nature of the liquid crystal material. And so you can see here, they are the texture corresponding to each phase. So by seeing these optical texture, you can identify which phase these materials are possessing. So what happens, because these molecules can be reoriented with the help of a applied field. So what happens is the bright and dark field. So basically it belongs when you apply the field, applied electric field or not. So basically you can reorient or these liquid crystal molecules using a magnetic field, electric field, pressure, and so on. So basically there are three main stimuli. So what happens, for example, here is a light source. So what happens when this light source emit a unpolarized light? So these are the liquid crystal molecules filled between the two electrodes that are basically ITU coated glass plates. And below here, below the ITU coated glass plate, we also put a alignment layer in order to align these molecules in like parallel to substrate or perpendicular to substrate. So when it passes through the liquid crystal material, it becomes partially linearly polarized. So in this situation, light passes through this liquid crystal molecule because they are birefringent in nature, and after that it becomes polarized and we receive a bright state. But what happens, so please remember, this is without field when we don't put any field. But what happens when we put the field, what happens, molecule, we are putting the field along this jet direction, that is in jet direction. So what happens, all the molecules, they also align along the field because these molecules have definite amount of dipole moment. So what happens in this situation, light do not pass and we observe a dark state. So planar cell at threshold voltage is like this. So when we do field on and off state in twisted pneumatic LCD, what happens? So you can see here the structure. So basically we fill liquid crystal material in between the P, G, and E. So basically P is polarizer. So basically we use polarizer and analyzer. G is your glass plate. E is electrode, transparent electrode. I stand for the image and L stand for the light. So basically you see here when this is off, there is no field here. So what you see obtain here the on state. And when you put a field, molecule orient perpendicular to substrate and you cannot see any image like that. So this is the basic principle that whether you will obtain an image or anything on your LCD screen or not. So basically this is the operating principle. So now you would be interesting to know how LCD works and what are the components, because you only see the screen of LCD, but you don't know what is inside that. So here is the architecture of a LCD displays. So basically this is the screen, what you see on your television. Behind that, this is the cover glass, and after that, this is the display surfaces. This is the horizontal polarizing layer, and each LCD, it need a RGB color filter in order to produce color to your images. This is the top electrode. This is a layer of liquid crystal material. This is the bottom electrode, and this is the vertical polarizer layers, because you need a polarizer and analyzer at a 90 degrees. And after that, this is the mirror, and this is the electronic circuit which is connected to all these. And we used a frame. here. So this is the architecture of a LCD display. So basically now after knowing the structure, you will be interested that how it works, how it is made in the enterprise or in company. So in the next, I have put a video here, and I will show you. I will try to show you a video that how crystal display is made. So basically, these are the processes which are needed during the fabrication of the display. So basically, these are the substrate, glass substrate. So first we do the cleaning of these glass substrates, and then we deposit a thin film, basically for the electrodes one.
Dr. Dharmen, we are not able to see the video.
You cannot see it?
No.
Okay, so you are able to see the video, or you just you cannot hear the voice?
Your voice is perfectly all right, but the video is not playing.
Video is not playing. Okay, I just try. Is it again?
No.
Okay, sorry for this. I just escape it and.
Yes, you can you can continue with the other slide.
Okay, so basically this, I just one time maybe I again. Is it visible now?
No.
Okay, no problem at all. Okay, so basically here I tried to put a video that described that how a display device is manufactured in a enterprise. So basically this was the functioning of a low temperature polysilicon liquid crystal display. We say it LTPS LCD. So basically, okay, I can explain you here in brief. We have a is here, and after that we put a backlight unit. So basically because liquid crystal doesn't have their own light and its molecule need a light to transmit, so we need a backlight unit, and after that there are some diffusion light guides, and after that we use polarizing films here, and this is the TFT here, liquid crystals here. After that we use a color filter and a polarizing film, and this is the pixel unit. Okay, so every LCD display have a different number of pixels. So I think I don't know whether what is you again can see this. I again put the video about the person who was the inventor of the LCDs. So it was a Martin Satt, a Swiss physicist who first time discovered the LCD devices. So I try to, can you see it again or not?
No, Dr. Dharmen, only voice we are able to listen, but to the video we can not.
Okay, maybe maybe it's a problem.
Yes, I think there is some problem.
Okay, so I just maybe I okay. So sorry for this inconvenience. Maybe I will give you the link where you can see these videos, and
Yes,
you can
you can
start with
share
these people.
links with the chat box or You can share these links with my email, then I can send to our
Yeah, later. Oh, yeah. Okay. Thank you, Prince. I will share the link of these videos to you, and later on you can put on a web page of your college or something, so that our audience can see these videos later on. Okay, so I want to tell you about the Martin Short, who was the man behind the LCD discovery in 71. He was working in a Swiss company where first time LCD display was discovered. So after 71, it took around 10 years, more than 10 years, in 1984, when super twisted pneumatic display came into the market. So in which, like, because the performance of these displays was significantly dependent on the this twisting power of the pneumatic, because this twisting power happens when you apply the field, molecules twist from bottom electrode to top electrode. So the same colleagues in Switzerland, this is the company known as the Brown Boveri Research Center in Baden, Switzerland. They used like double layer super twisted displays. So they used the double layers of the twisted pneumatic matrix, and they put in between the off and off states, and they use the polarizer and analyzer, so that they have enhanced the resolution of the LCDs, which was like 514 to 270 pixels. So this was superior as compared to the simple twisted pneumatic based LCDs. So basically, okay, I again put a video to demonstrate you, because after this, some touch screen displays came into the existence, and nowadays touch screen display devices are very, very popular among the all generation, especially the young generation. So I don't know whether it can. I think it will also not working. I don't know why, because I put hyperlinks, but I don't know why it is not working. So basically, I can tell you the working of these things, because what happens, this is this will be the glass matrix, and it will have a very, very small areas where when you put your finger, so basically what happens, the field lines are distracted. So that field lines are attached with a particular function, and when you touch this screen, it gives a command to the microprocessor unit, and in your device is responded. So I will put this the link of this video as well, and after that, like, you can see this. So later on, if you have any question regarding this, you can ask me. So after that, like, this LCD based displays, they were very popular for the all in the society, and they were served our society for a long time. So after that, in 2003, OLED displays, they came into the market. And why they became popular? Because first time they used organic light emitting diodes. And because they use the organic light emitting diode in the LCD, there were no need for a backlight or side light, because in LCDs there is a need of backlight unit, because liquid crystal molecule, they don't have their own light to glow. So here it was very, very important discovery in the form of OLED displays. That was nothing but only the backlight unit was replaced by the OLED. So when backlight unit is not needed, the power consumption become half. So these two features, like, they made these OLED display very, very popular as compared to the LCD devices. So after that, LCD and LED and OLED devices came into the market. So basically, LED is a TV with the conventional LED technology that requires a backlight unit. We say BLU for the backlight unit to generate light that passes through the colored pixels. Okay, but in OLED devices, and OLED devices possess organic subpixels using organic light emitting diode, okay, that generate their own light. Due to this, they don't require a BLU, making OLED TV thinner than the LED TV. So this was the very nice feature of the OLED devices. And you can see it have very good contrast as compared to the previous, and even wide vivid angle and color gamut as well. So later on, nanotechnology entered in field of display industry. So I'm not going to tell you details about the nanotechnology because you heard a very fantastic lecture by Dr. Prabhat Dwivedi. But basically, in display devices, quantum dots has been used. So basically, quantum dots, what are the quantum dots? So basically, semiconducting quantum dots are used. You heard about other type of nanomaterials as well, like metallic particles, insulating, and so on. You heard a very good lecture in the morning session. So basically, here in the display, only quantum dots are used. Why they are used, I will tell you in this slide. Because quantum dots now, they are colorful component for the present and future of the display devices. So basically, quantum dots is a portion of semiconductor whose exciton are confined in all three spatial dimensions. So properties of these quantum dots, they lie between the bulk semiconductor and discrete molecules. And you can tune the property of these quantum dots by changing their size, because they follow the quantum confinement effect. So on behalf of quantum confinement effect, you have heard and you have studied this principle in your quantum mechanics. So on behalf of quantum confinement effects, these properties, especially the optical and electronic properties, are size dependent. So for example, if you increase the size of quantum dots, you can tune the optical property, and this particular property has been utilized in the display devices. So first time the concept of quantum dot was discovered by a Russian scientist, Alexei Ekimov, and at the last the term quantum dot was coined by Mark Reed at University of Yale. So after utilizing these quantum dots in QD LED displays in 2015. So here the role of nanotechnology in display industry came into existence. So basically, quantum dot based backlight has greatly enhanced the color contrast, wide color gamut, and better optical efficiency for the LCD display. So you can see here the structure. When you use the quantum dot as a backlight unit, you enhance the color contrast and white color gamut for these display devices. So you can see this QLED TV, which have many advanced features as compared to the previous display devices. So here is a small tip for you. Next time you go to shopping for a TV, check to see if it has a color IQ, QLED, QD, QTD, quantum, or similar label on the set or in the user guide. That tells you that TV uses quantum dot technology. So that is a really very fantastic technology. So why and how quantum dot are serving to display? Basically, pure quantum dots based display are not into the market now, but many scientists are trying, and many companies, including in China, Hong Kong, and South Korea, they are still working to fabricate the pure display using quantum dot. But at the moment, pure quantum dot based display devices are not in the market. Only the quantum dots are used in the display devices as enhancement film and color filters and emissive displays. So here you can see the structure of these quantum dot display technology. So you can see here we use a white LED as a backlight unit, and after that light guided film, vertical polarizer, horizontal polarizer, and in between liquid crystal and color filter are used. So second, in QLED devices, there is a more complex structure. In backlight, blue LED, instead of using white LED, they use the blue LED here as a backlight unit. And here they used a transparent film of quantum dots, okay, and liquid crystal and so on. So by using the quantum dot, they have enhanced the color contrast and color gamut. And when you use a colored quantum dot as a color filter, here you can use like this. So blue LED is used as backlight unit, light guided film, vertical polarizer, horizontal polarizer, liquid crystalline in between, and here the color filter based on the quantum dots. So basically you enhance the efficiency of your images, color contrast, and some other features are really advanced as compared to the previous devices. So now I present you a comparative study, comparative details to know which display is better, which display is not better. So basically quantum dot or QLED TVs, they have the color performance on par with the OLEDs, that is greater color performance. Maintenance excellent, color saturation as brightness changes better than the OLEDs, because when you use quantum dots, their contrast is really better as compared to OLED devices. Absolute back canard display, uneven screen uniformity. There are some problem as well with these type of screens. A narrow viewing angle as compared to the OLED devices, and highlight output capability. So these are some features and drawback. And these are the features of the OLED TVs, like excellent color accuracy, not good as quality LED, and maintaining the color saturation. Color saturation is a problem in OLEDs because OLED organic light emitting diode, the molecule which are used, they have the limitation of this. Can display the absolute black, not as bright as QLED TV. Okay, better screen uniformity because these are organic molecules, and low power consumption because here quantum dot additionally need a power. But OLED, organic light emitting diode, the molecule which are used, they need very less power, and more expensive than quality TV as well. It's one is the cost is one of the matter. So this is the overall comparison between the LCDs, quantum dot based LCDs, OLEDs, and the micro LEDs are nowadays in fashion. So you can see LCD is low cost technology. That is one of the best advantage of the LCDs. This is a mature technology and largest display market it is covering at this age also. So in quantum dot base, they have enhanced some photoluminescence and white color gamut because quantum dots, they have very fantastic emission of the light. They can possess photoluminescence as well as electroluminescence. They are more stable as compared to LCDs. Self-emissive white color gamut, and it can be processed by the solution method. So you can fabricate the large screen by solution processes. And OLEDs as well, they have some feature of high contrast and wide vivid angle as compared to this technology. And these are the micro LEDs. So micro LEDs nowadays are becoming popular because they possess low power, high brightness, luminescence efficiency is maximum, highest stability for the moment, long life, and large joint displays. So at the moment, these micro LEDs based displays are becoming very popular. Okay, so here I have presented a comparison between different liquid crystal display technologies. This is liquid LCDs, OLEDs, and QLEDs. So if you see the mechanism, LCD possesses color filter plus backlight, OLED are the self-emissive, QLED is the down conversion quantum dots plus micro LEDs. Luminescence is like medium in LCDs, OLED they have low luminescence, and QLED have very high luminescence. So luminescence efficiency is in same order, its the efficiency is low, LED is medium and this is high, power consumption, medium and low, contrast ratio, LCD is less, and QLED and OLED they are high. Lifetime of LCD is long, OLEDs is medium, and QLED is long. Response time in millisecond, microsecond, and nanosecond. That's why like they show a better image response as compared to LCDs. And these are the WBTR requirement. This is a technical terminology. And flexibility and cost. So basically, flexibility of LCD is very, very low because they use ITU coated glass films, so it can not be flexible. So this is the one of the demerit of the LCDs in order to fabricate the foldable devices. But OLED and QLED, they are very, very flexible, and that's why on behalf of these two technology, you can fabricate the curved screens or foldable displays as well. So with LCD, there is one very important factor of the cost, because this part is very low cost, but as compared to the LCD, OLED have the high cost, and for the moment, QLED's cost is not determined because it is still under research and development. So basically in this talk, I didn't I didn't include my research work here, because basically we have recently started some work on the displays. So basically what we do in our laboratory, we do measurement for the charge transports in the different devices, including the display devices. But basically we are measuring the charge transport property in photonic devices and photovoltaic devices. And we are measuring some other electronic properties in photovoltaic devices or photonic devices, electro-optical devices, and display devices, morphology, and so on. So these are the current areas of research. So if you are fascinated to work in this display technology, and you are also like interested to work with the nanotechnology, so what are the opportunities? So in conclusion, I could say it have still plenty of opportunities, because many people, they claim that liquid crystal based display devices, this field is going to saturate. Yes, of course it is going to saturate, but still you have plenty of things to do when you merge the nanotechnology in the display industry. So future of strategy, it could be like front of display, greater efficiency, brightness benefit, complete foldable devices, not only in the form of gadgets only, but in the form of other things also. So still like I could say that this field have many opportunities, and especially this is very important for the young researchers and students in the bachelor and masters to decide their objective of the career. I would like to thank my collaborators, because not only on the display, basically I didn't do a lot of things on the display, but basically we are currently working on the energy and photovoltaic devices over the liquid crystals, especially with using the discotic liquid crystals with some of my collaborators from India. Professor Sandeep Kumar, Professor Santanu Pal, Sanjeev Namdar from University of Karnataka, Professor Patiko Mukar, my supervisor as well at University of Lucknow, Professor Achal Kumar and Professor C.V.L. Maggan in Bangalore. I have many collaborators in European Union as well. My collaborator in Belgium, my collaborator in France, and my collaborator in Germany. And in addition to that, I have some other collaborations in Australia. Basically, very recently, Professor Non has moved to Australia from New Zealand. My young colleague and collaborator from South Korea, we have like one mobility project, and we are trying to develop some new type of nanomaterial that can enhance the quality of displays and sensing properties using waste materials. There is one very famous center of the display technology, and this center is headed by Dr. Abhishek Kumar Srivastava, who was my senior as well in the University of Lucknow during my PhD. And so his center is really working very nice in the field of display devices. So I have some other collaborators from Thailand and some collaborators from United States and Canada as well. So I would like to thank my funding agencies as well, University of the Littoral Opal Coast. This is the eyesight by which I got so many mobility project. Hot de France region, who financed my PhD projects. Irene, with whom I am working, availing some facilities, instrumental facilities, as well as one internal university project. This is another regional funding agency, and of course Campus France, which have given me this Charpak fellowships in the form of this. And this is the center of the Pole MTE, which is a university center which gives money to the researchers inside the university. I would like to announce something if young researchers are interested. All French University, they are opening the thesis project call in January 2020 to January and February 2021. So some calls are open, and at present I have also one thesis project which we have submitted to our university, and we will be looking for a candidate for this this project. So in addition to that, my laboratory and my university, they all time welcome the Charpak Exchange Fellowships for the master student and PhD student, as well as Charpak Lab fellowships for master student if you want to do some summer internship in France. And in addition to that, there are two excellence programs for the masters and PhD student. And for the PhD students, you have a very wonderful platform, like we say CEFIPRA, Indo-French Center for Promotion of Advanced Research, and doctoral student, they can avail this Raman Charpak exchange program. So if you want more detail, you can go to my webpage, that is this, you can search even on the Google also. I also want to do a small announcement. We are going to host two conferences in August and September. So first conference is on self-organized anisotropic system, we call CFCL 2021. It will be held in Calais, in my city, from 31st August to 3rd of September. So I invite you all for submitting abstract, and if possible, I welcome you on behalf of the organizing committee and my laboratory. I welcome you and I invite you to visit France and to participate in this conference. In addition to this, there is another conference that is the International Symposium on the Dielectric Materials and Applications. And this will be followed, initially will be held in addition to a summer school on the energy. It will be from 13-14 September 2021, and this conference will be going on the 15 to 17 September 2021. So it will be my pleasure to welcome you here, and I wish that I could see some of my friends and colleagues here over these conferences. So at last, I would like to thank you all for listening me, and I would love to answer if you have any question.
So thank you, Dr. Dharmen. Now the question is, now the session is open for question and answer. If you have any questions, you can ask directly. I don't think there is any question. Dr. Dharmen, but I have one question.
Yeah, sure, Prince.
That you talked about the quantum dot in the field of display industry.
Yeah.
So could you please elaborate more about, I mean, how the quantum dot is useful to make more efficient LCDs and display devices?
Yeah, basically they were using the color filters basically to produce the RGB color and its color combination. So basically, because as I told that these quantum dots following to the quantum confinement effect, and on behalf of their size, they can emit the light of different colors. So instead of using the conventional color filter, you can use the quantum dots, because the quantum efficiency and quantum yield of these quantum dots, that is much better than the ordinary and conventional color filter. You can obtain more contrast display devices, and the color gamut is much improved when you use the quantum dot. As well as you can use a quantum dot based color filter as well. So quantum dot are not directly used to fabricate the display devices. So for at the moment, a lot of discoveries and research is going on currently in the at present, but at the moment, quantum dots are used only as helping agent in the display industry, not as the main display material.
Okay.
But in near future, maybe you could see a display device that is completely based on the quantum dots.
Okay, it means lots of work has to be done in the field of display devices as far as the quantum dot is concerned.
Yeah, definitely. My friend and my co-author in this chapter, Dr. Swadesh Gupta, he was working for one company in Hong Kong and China. They are trying to develop this display device only using quantum dots. But meanwhile, he got the job, and recently he joined D.S. College at Kanpur. So it's still like company is not closed and worldwide working is going on. So I hope, like, I'm not very much a technical person who I never worked for the industry. I work on the laboratory level, like unit level of the display properties. So maybe when you will organize like a webinar on the greater scale, maybe 1 day full or 3 days workshop like that, maybe you could invite other people like who are working in the industry, so they can demonstrate directly to display devices. It will be helpful for the students and especially the young researchers like PhD student to inspire them to working on the new modern technologies.
Yes, definitely. One more question I have.
Yeah, of course.
That you know that you said that the efficiency and power consumption in display devices. So how do you calculate? The efficiency and the power consumption. Is there any formula or what are the parameters or factor you measure in the laboratory for?
Yeah, basically there are
because I am not particular in this field, so that's why I'm asking.
Yeah, there are testing units for all the displays when they fabricate, and there are various formulas by the calculate also. And when they use the quantum dots, they use the CIE coordination, like CIE. You can search in some papers, like they have to show the emission of the quantum dot and so on. Like, so there are various parameters, and of course there are formulas to calculate all these parameters.
Okay.
And for the power consumption, like for example, because this display devices, they are made of different components. So basically different components consume the power. So that's why, like, for example, when you don't use the backlight, when you use like OLEDs, they have the self-emissive property. So you don't need power for the backlight unit. So that's why the power consumption becomes half. So that's why, like, we calculate the power consumption by the individual compound, and that's why, like, we calculate the overall power consumption of the display devices. So of course, there are plenty of opportunities also for minimizing the power consumption by the display devices.
Okay. Thank you so much.
Yeah, you're welcome.
So now I would like to invite Dr. Suresh Kumar Sajan to deliver vote of thanks for this session. I am audible?
Start.
So
Okay.
Dr. Suresh Kumar Sajan is an associate professor in Department of Physics in our college. So now once again I'm requesting Dr. Suresh Kumar Sajan to deliver vote of thanks.
Okay, thank you so much, Dr. Prince, for giving me this opportunity. On behalf of all the participants and all organizing team, I would like to thank you for your very informative talk. You told about applications of nanotechnology in terms of display devices and how to reduce the cost of these display devices by using nanotechnology. Thank you once again for your wonderful talk. Thank you.
Thank you, Dr. Sachan.
So, thank you, Dr. Dharmen, for this your valuable time.
Thank you, Prince. Thank you for inviting. For me, today is Sunday. That's it. I was completely free. But really, I'm sorry I couldn't join the morning session completely because, you know, there is a time lag between Indian time and French time. So France is lagging by 4 hours and 30 minutes like that. So when it's morning is in India, it's already night in France. Early morning to me, it's still around 8. Yeah, it's 8. It's going to be 9 a.m. in the morning.
Okay, okay.
I really wanted to listen to Dr. Prabhat Verma because he's really very working on a very nice field. And nanotechnology is one of also my very fascinating field.
Dr.
So,
Dr.
I couldn't.
Dr. Dharmendra, Dr. Prabhat sir is listening to you.
Okay, so maybe I will discuss with him when he will be free. It will be nice to discuss with him, and definitely, like I know many of my friends and colleagues, they are serving Kanpur University in different colleges. They are serving, and really nice to see you all giving your valuable contribution in field of education. And basically I'm really very happy to see my young and dynamic friends who are in different degree colleges, and they are really doing very nice within the limited infrastructure and facilities. So basically I could understand because I also belong to Unnao. I know the facility what you have in college, but within these limited facilities you have this enthusiasm to do all this. It is really praisable. So I clap for your uh, your dedication and so on. So thank you. And really I request you, Prince, and all your colleagues in the department, your HOD physics, all your colleagues who are in the department, you can organize more and more this type of webinar. If you need any of my help, without any hesitation, you can ask me. And really it will be nice for you, your colleagues, your students as well, in order to make the students aware about the new technology, modern technology, in order to enhance their interest in doing research and so on. Because in India, we really need to correlate our research, our knowledge with the industry. What lack, even Dr. Prabhat Verma also pointed out that we need to attach the industries with the research units, what they are doing with the laboratories, to farm the products and so on. So it will be really nice to see you all of you in the any new webinar in the future. Thank you, Prince, and thank you all honorable members of this organizing committee. Thank you so much, and I wish you have a nice day.
Thank you. Thank you, Dr. Prabhat.
Thank you, Dr. Zundan.
So this concludes the webinar. Thank you all for attending this webinar. We hope you have learned a lot and enjoyed, and get in-depth knowledge and information shared by our speakers in this webinar. So once again, we will try to organize different conference, and we will get back soon to the next conference. Okay, thank you. Now I'm going to this thank you once again, Dr. Dharmendra and Dr. Prabhat, for sharing knowledge. From behalf of all the organizers and participants, thank you so much.
Thank you.
Okay.